Hello, my name is John Strabela, and I am a Principal Product Manager here at Couchbase. Today's session will be the evolution of the eventing service and why upgrades matter. Okay, so eventing is one of the youngest Couchbase services, having been introduced in Couchbase Server 5.5. As such, it has been evolving at breakneck speed. Customer feedback has been essential, and it has driven new functionality and many performance enhancements. Okay, today we'll be going over a brief introduction of eventing. Then we'll do a quick demo on the current state of eventing. Then we'll talk about enhancements prior to version 7.0, enhancements in version 7.0, and the latest enhancements in version 7.0.2. Eventing leverages the familiar JavaScript language, and it makes it easy for developers to build and maintain business logic close to their data. Functions process and respond to data changes in an event condition action model. And a data change is termed a mutation. Functions are written in JavaScript code to analyze and manipulate your JSON documents on each and every mutation. Typical use cases include threshold-based monitoring, monitoring parameters, propagating changes, enriching documents, scheduling future actions, data cleansing, and then we have point tools. And finally, we have external REST interaction. So on the right, we show a particular document that will enrich the data by adding another field based upon an IP string. It'll split it up into parts that could be easily indexed and manipulated. So pictorially, let's look at what eventing looks like. We have DCP, which is a fire hose that just streams data at a massive speed. Eventing can pick up the DCP feed, and as a post trigger, looking at any change, whether it's an upsert, an insert, or even a delete, it will process things and it will respond to those changes, and it can write back to the database. It can use curl to talk to external REST APIs and other databases or other external queuing systems. And of course, these changes can come from the left-hand side via SDKs or other applications. So we centralize this business logic, and it's co-located with the core data service. So the actions occur in real time in response to changes in data. Once again, we use the familiar JavaScript, and because it's a first-class Couchbase service, it easily scales both horizontally and vertically via MDS, multi-dimensional scaling. So the user doesn't have to concern himself with any of the underlying infrastructure. It just works. So here's a couple more eventing functions. The one on the left, data reduction and sharing. Say you wanted to share a user profile with a business partner. This will strip out sensitive data and only give a couple of pieces of a user profile and write it into a bucket, which we might use XDCR to stream across to a cloud service, another Couchbase server that the partner uses. This is kind of an elegant, very short function. On the right, we show external REST integration. Both of these are examples on the scriptlets or examples page in the embedding documents. The curl request is actually grabbing an exchange rate and writing it to a particular document. In this session, we're only going to do one demo, and it will be based upon a blog. Here's the link to it. Okay, now that we've finished our quick introduction to what eventing is and some samples, I'm going to take some code that was loosely based upon this particular blog on blog.couchbase.com. And it's a fairly straightforward and simple function. And as you can see, it's not very long, 50 lines of commented code. And what this will do is this will work on 10 million documents. These are documents that have an XML string. So let's take a look at the particular documents, which are in a key space of source, integration, and XML data. So our particular documents look like this. They're all fairly similar. They have a type, XML, an ID, and then a string with of XML with a property in_XML. So they're all similar. There's probably about 20 or 30 different variations from a generator that I used, but we have 10 million documents. And what we're trying to do is showcase what eventing is really good at. And so I will deploy this eventing function with a feed boundary, which is built in for everything. It has certain settings in it where it has a source collection of a key space, source, integration, XML data, and it has access read-write. So this will update the source bucket, which was introduced in 6.5. It will also pass a constant debug, and that's set defaults because I don't want it to print anything. This was introduced in 7.0. And up at the top, we have what we listen to. We have an eventing scratchpad key space, function name, and our feed boundaries from everything, okay? Because we want to convert everything. The last thing is, we used to have 3 workers in the 5.5 through 6.6 series. Now by default, we have 1 worker, but when you increase the workers, you actually increase the performance of eventing functions. Typically, you could set this to the number of vCores. All righty, so now we're ready to just deploy this function, and we'll see how performant it really is. And we'll also see in real time with charts that have been introduced recently in 7.0, when the function comes in and it starts to run, it takes about 15 seconds to deploy. Eventually, we will get some charts that are lagged by about 30 seconds. And as you can see, the eventing function here is incrementing. We almost have an entire million items processed. And I'm going to pause this just briefly. Okay, so now we have about 1 million documents or mutations left to process. And as you can see, our invocation rate is about 66K, 63K, and we're tapering off right now because we're almost completely done. As I said, the invocation rate is lagged. We just have a couple more documents to get across and finish, and we are now complete. So if we take a look at, hey, what are our documents now? Remember, we used to only have the in.xml string. Now every one of our documents has an out.json, which is a indexable, queryable via NCL or SQL++ document. And it also has a checksum. And what we use the checksum for in this particular sample is to prevent doing work again. So this function is still running. And right now in real time, if I changed Elton John to Sir Elton John, we save this document in the editor, and we take a look at it. Well, we have Sir Elton John like we changed it. And guess what? The XML immediately was translated into JSON. We see Sir Elton John. We can obviously put it back, save it, and we take a look at our document again, and Sir is gone. So I'm just showing you that we have almost instantaneous, near real-time updates of our documents via eventing as a post trigger, listening to mutations on your documents. So let's take one quick look. Did we get any logging? No, we got 0 logging. And that means there's no errors, and we did turn the logging off. Let's undeploy this function and deploy and undeploy. They both take about 15 to 18 seconds. Once this function's undeployed, what we're going to do is we're going to run it again. And it will actually run faster this time because we will do a checksum and we'll prevent some extra work. So we're going to hit deploy again, and we'll see how fast we can tear through this pool of 10 million documents. What we do in this case is we'll calculate a CRC64, we'll read the document, and if it comes in through the DCP fire hose, and this is going to get done really, really fast because we don't have to do much. We just check that the CRC64 is correct, and we don't perform any bucket ops. And as you can see, we're almost at 10 million right now. Okay, let's just jump right in about the enhancements prior to version 7.0. Eventing was introduced in 5.5, and these are the key features. Almost all of them we'll go over in the next slides. Of particular import is the ability to update documents in the source bucket or source key space. And as you can see on those comments at the top, when we directly manipulate via KV, it's much faster than manipulating documents via nickel. In 6.5, we introduced pause and resume. Okay, that allows you to stop your eventing function and make an adjustment either to your JavaScript logic or perhaps increase the number of workers, and then resume the function without missing any mutations. Also in 6.5 and in 6.5.1, curl went full production ready. And curl allows you to communicate and talk to external REST endpoints. You have different types of authorization. And what we do is we make an alias that's a binding to the function. So the function in this case, in the JavaScript, would just reference exchange rate API, and it would talk to that particular URL. In 6.5.1, we introduced per function statistics that are co-located with each of the function's controls. This allowed easier debugging. As you can see, we have a success count, timeout count, a failure count. And what it allows is that you can accelerate your development because you get immediate feedback on something that's going wrong. The image on the lower left shows a high number of failures. And when we open up the function itself, we get positioned where that failure is occurring. And as you can see, CNT equals 0, we are missing a var or a let. So there's no more switching to other screens to try to find or monitor a key statistic like failure. It's all co-located, and it makes creating and debugging your functions much more enjoyable. Also in 6.5.1, we went from 10 bucket support to 30 bucket support. And while we did this, as you can see, deploying 5 eventing functions took almost 2 hours on 30 buckets. But under 6.5.1, each eventing function takes a constant time of 89 divided by 5. You can do the math. It's about 15 to 18 seconds per function. So that's an enormous improvement in usability and also scalability. Moving along into 6.6.0, you have the ability to differentiate between expiry and delete on the onDelete handler. So you know what it was that removed a document, whether it was a TTL expiring or whether it was an SDK deleting the document. Also in 6.6.0, we've improved functionality where if you need to have a recurring timer, the language natively supports that. Prior to 6.6.0, you used to have to turn off inner bucket recursion and have a helper function, and it was much more complex. In addition, timers can now just be canceled by their reference, or timers can just be overwritten, which is the same as canceling a timer and creating a timer with the same reference. Furthermore, in 6.6, a regression that solved a particular bug where we had timers put way in the future that caused a growing amount of CPU and ops. Typically, customers use timers in the the close time horizon, but we found that some customers were starting to schedule things like a month or 6 months in the future, and that exposed a bug that had to be fixed. And in 6.6.1, we introduced advanced bucket accessors, now called advanced key space accessors in 7.0, that allow you to use a richer set of operations to manipulate TTLs, to utilize CAS when you have hot documents under high contention. And we also introduced distributed atomic counters, both increment and decrement. Here's an example of TTL and expiry. Every document that is processed, if it doesn't have an expiry set, we'll add 90 days to the current time and we'll set an expiry. Pretty simple function, really easy to do. And here's an example of using CAS to solve contention issues. It's a while loop, and it will continue until it actually succeeds. So the idea here is you're listening to a large pool of documents, and each document is trying to update a document with a key called hot doc. And we end up in our loop always reading the document, manipulating the document, then we try to write the document, but if we get a CAS mismatch, we have a failure. And when we have a failure, we just loop over and over until we successfully write our document. Some enhancements for 6.6.2. We support binary documents. And of key in the eventing settings, if you open up the expandable area settings, there will be a language compatibility mode. And only 6.6.2, which is the highest today, will allow the use of binary documents. If you have any compatibility setting prior to 6.6.2, the binary documents will be completely filtered out and not seen by your eventing function. We've also introduced the feed boundary as sticky with the function itself. Prior to 6.6.2, you would always choose if you were deploying from everything or deploying from now when you hit the deploy button. There are some use cases where customers always want to deploy from everything, other use cases where they want to deploy from now. By binding this tightly into the function settings itself, we've eliminated a lot of operational mistakes. And if you need to have a larger context size, in other words, the state of a function, when you want to defer its execution for n seconds, minutes, months, you store that state as a JSON document in the timer context. You can change this on a per function basis if you need more than the defaults of 1024. And finally, we introduced find and replace capability in the JavaScript code editor, so you can easily be case sensitive or do words only and refactor code. This makes the editor a lot more useful. Now, moving right along, the enhancements in Couchbase 7.0. Okay, all eventing functions now listen to a single collection, and a collection is part of a key space. Key spaces are bucket, scope, and collection. So as we can see in the upper right, we have a bucket bulk, keyspace cust1, and collection orders. Eventing storage also goes to a collection. So we have a bucket RR100 for resident ratio 100, customer 1, and metadata, which is the eventing scratch pad. I call it RR100 because I like the eventing storage to be memory resident completely for high performance. The other thing that we have is the ability to share this eventing storage, just like we did the buckets, across all of the tenants' eventing functions. Okay. The optional bucket bindings is binding to a key space all the way down to a collection, bulk cust1 orders, read write. This means the function can write back to the source of the mutations using this particular alias, orders underscore bucket. And we can also, in the collections world, bulk cust1 shipments. Now, the interesting thing that now that we're in the collections world, we can operate in fewer buckets, which is less resource intensive. So here's a layout of multi-tenancy. Okay, here we have customers 1 through N, and on the left we have a high memory residency bucket, and on the right we have a low memory residency bucket. Here's a different type of layout for single tenancy. On the left, we have the eventing scratch pad, and we might have things that are fairly hot collections. And on the right, we have things that need to be accessed less. Collections allow you to organize your data much like our DBMS tables. Now, in 7.0, we now, just like we backported to 6.6.2, the feed boundary, we've introduced something called a constant alias, which works just like a global in your JavaScript function, but it's done via the settings. So, and the settings of the function. And then in the advanced expanded settings, we now allow you, just like we do in 6.6.2, to change your timer context match size. Constant aliases allow you to do interesting things like passing a debug level into your function to suppress printing items in production that you would typically want to see in development, or setting a threshold, or passing in a key prefix to a generic function that's a point tool that you, let's say that you possibly wanted to delete everything or archive everything with a particular prefix. You can also pass any sort of template or object. You can do a number, a Boolean, a string, or a JavaScript object down there at the bottom. We also have a few other operational enhancements. The ability to set up an alternate address, which is like a tunnel to get through NAT, which helps the eventing debugger. The application logs now summarize your exceptions. Instead of sending them across all functions into a common eventing.log, they summarize them and send them to each function's specific application log, which is very helpful. The key rate charts are now co-located with your function controls, just like the statistical counts that are numeric. We have schemas that allow you to define eventing functions as long as you adhere to the schemas. You can create your own eventing functions outside of the UI. However, we recommend using the REST API. You might want to just create your JavaScript code bundle and then update that. There's a new endpoint called app code, which allows you to transfer your eventing functions from development to production easily, but leave every setting and binding the same. We also have new REST API endpoints, such as limiting the status to just one function. We have some security enhancements, the eventing full admin role and the backup full admin role, which allows eventing to be run without super user privileges, where it can't create another user or change the access credentials of any other user. So it's a security enhancement. Now, in Couchbase 7.02, we updated the exception logging to always log the first exception and then give the summary 60 seconds later. So for each thread, you would get 2 items. For every 60 seconds, this speeds up debugging. And finally, we have bucket-backed caching. This is a node-based cache that lasts at most 1 second. The caching provides read your own write semantics, and the performance is up to 22 times faster than a direct KV read from the data service. So what I want you to understand here is that this is perfect for static data or lookup tables or slow changing data. If you need to utilize like a lookup table for financial data, like current exchange rates, that only changes once a day, this is an ideal way to speed up a join within eventing without dropping down to KV for every mutation. So the key points, we now have collections, we have operational improvements, we have enhanced security, and we have increased performance. So I'd like to thank you, and that concludes the session. The last slide will be a few resources that you might want to visit.